Stanford University.
All right, guys, welcome to CS 193P Lecture 18. We're kind of starting to wind down here, just 2 lectures left. So, I'm sure everyone's already done with their final projects by now, probably, right? Yeah, well, all right. So today we've got a little bit of a grab bag. It's a bit of a mix of things. We're going to start out talking about unit testing. Arguably, we should have started out talking about this at the beginning because you'll have wanted to use it all along. But we're getting to it now, so better late than never. Then we're going to kind of get into some. This fun with Objective-C is basically what not to do and how to do it. So we'll talk about that for a little bit. And some of that actually gets into how the unit testing stuff is implemented, and it's actually really interesting stuff and gets into some of the meat of the way that Objective-C works and the things that make it so dynamic and cool. So that's actually a lot of fun. And then maybe a little bit less exciting up front, but definitely no less important than the other things. We'll talk about localization. So, the App Store is available in countries all around the world now, and you can write your app and deploy it to all these different countries. You want everyone who downloads it to be able to read it and understand what it is that your app says. So we'll talk about how you can localize your app into multiple languages and get your nibs and strings to lay out correctly and show the correct words and stuff that people can actually understand. And we'll end up with some. This is the real grab bag part, I guess. We'll talk about some questions that we've gotten through emails and basically frequently asked questions kind of deal is what we'll finish with. All right, so let's start out with unit testing. Some of you may have heard this. Anyone's done unit testing before? Have seen it in other classes? Yeah, a little bit? All right, well, so there's a couple of other unit testing frameworks for other languages. We have one for Objective-C as well, and it's actually part of the iPhone SDK. But before we get too much into that, I guess it's important to know what exactly a unit test is. So unit test, the idea here is that you want to test specific areas of functionality in your code. You want to make sure that different bits of code are behaving the way that you expect them to behave, and that they continue to behave that way as you continue developing over time. You basically want your unit test to be pretty self-contained. Everything that they're testing should be functionality that can basically be wrapped up within the test itself and obviously the code that it's testing. You want to avoid external dependencies like networks, servers, and things that may come and go and not necessarily be available. And you want to run them frequently. The real idea here is that we're testing the functionality of the code that we're writing to make sure that it continues to work over time. So to make sure that that really provides us some kind of benefit, we want to run the unit tests often so that we'll notice failures up front and really quickly before they get checked in and become part of our code and hard to track down later on. So testing is kind of an interesting area, and traditionally testing has been done in a lot of companies as sort of a separate organization, or some other guy who does the testing, and he'll write some test code and maybe write some test cases, and maybe he'll have some user interface testing framework that plays with your device, using some sort of simulated input. And that's super useful and very interesting, and it's a great way to do testing. But this is kind of a different side. This is before that would even happen. The idea with unit testing is that you write the tests. The guy who's writing the code is also the person who's writing the tests. You really want to make sure that they sort of encompass the specific behaviors that your code is trying to actually achieve. The idea is that they're actually quite tied to the implementation and functionality. So ideally, they're written along with new code. As you're writing code, you want to write a test that tests that code so that as you move forward and change that code, it's working the way that you expect it to be. And a particularly interesting method of doing this with unit testing is to kind of flip the whole problem on its head and actually write the tests before you even write the code. So you can kind of start out writing unit tests that test the behavior that you intend to implement in your classes. So this may seem a little bit odd, and I've gone back and forth on how I feel about this throughout my career, and sometimes I find it much more useful than others. I think you'll find it depends on the project you're working on and the specific case. But I definitely do believe that there are many instances where it's a very interesting way to do things and definitely really useful. So basically just sort of the idea is you frame out your code that you want to write. So you define some method that you want to implement. And then you write a test case that tests that method does what it is that you want it to do. So you write the test case first, and then you write the code. So you're basically writing the code until such time as the test case passes. yeah, you've basically tested the thing before you've written it, so that once you're done, you know you're done because the test case works. That's where it gets a little hairy, because obviously test cases don't necessarily test every single aspect of the behavior of your application. But it can be very useful for that. And then you basically do the same thing over again, and you've got a new area of functionality you want to implement, so you frame it out, write the test cases, and then implement the functionality. All right, so you've got all these things written, but how are you going to run them? I mentioned that you actually would want to be running them fairly often throughout your development, and if you kind of leave it up to, I'll run this like once a week or once every day or something, it quickly becomes something that you very easily put off and say, I'll do it later. And then, 2 years later, after you've shipped 3 versions of your product, you're like, I should run those test cases again, and nothing works. So you want to avoid that. So the best way to do this is to actually have it be part of your build process. If part of building your application and your iterative development is actually running the test cases every time you build, and you don't have to do anything extra to make that happen, then they're just going to run, and you won't try and skip them. You'll just do it, and when you see a failure, you'll find it right away, because as you're changing your code, you're noticing the failures in your test cases. So that's a pretty common way to do it. So you can kind of think of it as another step beyond the compiler. The compiler is taking your code and running over it and turning it into machine instructions. But part of what it does for you is verify that your syntax is correct, right? If you've forgotten a semicolon somewhere, it's going to throw up an error and tell you that you've done this. You can kind of look at unit tests being run after that as a way of testing the semantics of your program. So the compiler is checking your syntax, but then once your syntax is all correct and everything's building and running, your unit tests are testing the semantics to make sure that the behavior that you think that your functions have is the behavior that they can continue to have as you change other things in the future. All right, so we've kind of covered a little bit of why you might want to do this, but let's enumerate a few reasons here. So first of all, the goal would obviously be fewer bugs. This is pretty much the goal with any testing. You want to catch bugs and eliminate them. The nice thing about unit testing is that you'll catch them earlier. I mean, if you've done a good job of writing your unit tests and you're covering a lot of the functionality of your code, you're going to notice pretty quickly if you've broken something, because one of your unit tests will fail. So it kind of gives you a couple of things from that. The first is that you've got a higher level of confidence that you actually are going to ship a quality product. You're pretty confident that the behavior you wrote at the beginning is still the behavior 2 years later after you've changed all your source files and rewritten everything from scratch 4 times. It also gives you that confidence to rewrite stuff. I've found some of the code that I feel by far most confident doing large-scale changes on is code that I have significant amounts of tests for. One example of that, it's an odd example because it doesn't actually use the framework that we're talking about, but I've done a lot of work on phone number formatting and matching on the iPhone, and it's one of actually the areas that I feel most comfortable changing code, because there's just a huge test suite of phone number validation to make sure that we're continue to format and match phone numbers the same way we always have in the past. So as we add support for new countries or change the way we do things, if something breaks, it's immediately apparent that a phone number we used to format correctly is no longer formatting correctly, or we're not matching this thing in the address book that we used to. So it really gives you a lot of confidence to change things and play around and come up with new ideas for how things should work without worrying quite so much about breaking things that you've already done in the past. So yeah, it also helps you to find the bugs early. They're a lot easier to fix when you find them before you've checked in the code that breaks it. If you check in a bunch of code and it causes some bugs and breaks some things and you don't notice for 2 months, 2 months later, when you find those bugs and go to try and fix them, you've probably got 9 other check-ins since then that are relying on the broken behavior that you checked in before. So now when you go and fix it, now you've got other things that broke that you checked since, and it becomes this huge mess of just entangled changes that are all relying on each other. If you can catch it earlier, it's much cheaper to fix and a lot easier, and you won't end up with this nightmare 2 days before you ship where everything is broken and nothing works. Not that that's ever happened, because it never happens. It also helps you, avoid regressions, as we said. As you're changing things, you'll notice if something broke, so you won't check in the thing that regressed functionality that you had correct originally. And it also actually helps you to document your code. A lot of the documentation that Apple supplies is obviously written by the documentation team, and there's also a lot of comments in the header files that describe how things should work. But the danger with both of those things is that they very quickly can become out of sync with the actual behavior if people aren't actually maintaining them. Documentation specifically it's written by someone else probably.